The overall sustainable objectives are nearly the same. The genius loci is different. Also, the circumstances of the campus in Munich. The energy concept is based on the infrastructure of the campus, which is the use of well water for cooling. The major skills of the design are dynamic reduction of the air change rates in the labs, also a topic which is in discussion everywhere in the world in the moment, and highly differentiated communication spaces. As you can see, the first sketch of the design concept, the border between lab and office spaces is nearly invisible. Offices and labs are in the same fire cut, as you can also see in the perspective. The corresponding building technology, which has to be that flexible too. The material concept is rough and reduced. Common areas are highlighted by warm materials like wood. The rest is rough concrete and visible technical infrastructure. The project in Jülich. The main challenge of the project in Jülich is the construction method based on wood-concrete hybrid construction. Because of the bad performance of the campus infrastructure, in difference to Munich, where we had the well water, the bad performance in regard to primary energy demand, we had to find a possibility to use the primary energy demand to reach silver level, even because it's the Institute for Energy and Climate. So this is the main topic I would focus on. A photo of the nearly finished building within the forest, which was also one of the ideas to catalyze the wood idea, and a perspective of the main entrance. The design is characterized by a huge two-level lab unit with 1,000 square meters with a central airspace for NMR devices, with corresponding lab, office and workshop spaces in only one fire cup. Remember, we have to build in wood. So the first sketches, and here's some drawings of the building and the final section. And some impressions of the construction period, which are dominated by the warm character of the wood construction, which looks like this in the end without covering of the surfaces. Now the project in Reutlingen, a college building for chemistry. Among the topics of the main challenge of the project in Reutlingen is the construction method of the facade. A solar shield is activated with photovoltaic panels. The geometry is designed to eliminate completely movable sun protection. Through this, the surface area for photovoltaics, which run the air-water heat pumps, is maximized. Roof and facade. That's how it looks like. And last but not least, the ELH, college building for the University of Berlin. The building has only one level of usable area because of urban and landscape reasons, as you can see in the picture. It has a huge photovoltaic roof. Also, the skyline is a picture to the agricultural situation around. It has a huge photovoltaic roof, and the total coverage of the energy consumption by air-water heat pumps with support of photovoltaic. Nowadays, everybody is discussing about heat pumps, but 3 years ago, when we won the competition, running a laboratory building with only heat pumps was very experimental. You see the site plan, you can see the situation within an agricultural institute and the border to the open landscape. The roof landscape with the integrated centralized spaces for the building technology. It's this. So it's the technical infrastructure for every lab. So we don't need fire protection system between technical infrastructure and lab. And the floor plan, which is very dense, and the section. Yeah, this is the technical infrastructure for the labs. Short summary: by focusing on the outcutted projects, I try to show you our approach to create green science buildings, which is visible throughout all the projects. I hope so. Nevertheless, every project has special challenges which depend on the given circumstances. My hope for the future is that we'll have a great variety of experience which can be combined for the development for future solutions. That gives us a chance to face the even more challenging future that is ahead of us. Thank you.
So many thanks for showing the different possibilities to realize sustainable buildings. Steffen, perhaps you can stop sharing your presentation, and then I would have a direct question to you, Steffen. If I want to build a very sustainable science building, what would be the 3 biggest points for you to think about? So you showed many aspects: construction with wood, photovoltaic, and pumps, and so on. What 3 aspects do you want to show or start with?
We start with the concept. What I think is common with all the projects I show is a very deep floor plan, which has a very strong structure. First, you think all the labs look the same, or they actually are the same. But in the end, we found out after several projects that if you have found the right structure, you're completely flexible to integrate all the needs of the scientists. And these structures are the basis to create flexible technical systems for the building, and also to reduce the surface of the facade. So this is the first thing, just to reduce the impact and to design a building which is that flexible that you can face all future needs without changing things. Mm-hmm. After that, you have to analyze the circumstances. Do you have technical infrastructure or not? Do you have well water, or you have to create a single thing? For example, the Berlin project, we had the competition with 1 level because of urban situation things. And then we said, okay, 1 level is actually a strange answer to a science building, but then we have to create a huge photovoltaic roof, and we have to use this for running heat pumps. So the impact to use heat pumps came from the architecture, not from the engineers in the end.